Welcome to this video on mean absolute deviation. By the end of this video, you should be able to determine the average distance each data value has to the mean by using mean absolute deviation. Alright, so mean absolute deviation is a measure that gives the average distance of the data values to the mean. So we're just saying on average how far away are the data values from the mean. Okay, so let's take a look at our data set. 2, 4, 6, 7, 8, and 15. So we're going to find the mean. So you would add together 2, 4, 6, 8, and 17, and you get 42. And there's 1, 2, 3, 4, 5, 6 terms. So this has a mean of 7. Okay, so we want to find the distance each data value is from the mean. So the word absolute is in this absolute value because we're talking about a distance, and distances are never negative. So 2 and 7, they are a distance of 5 away from each other. 7 and 4, they're a distance of 3 away from each other. 6 and 7, they're a distance of 1 away from each other. 7 and 7, they're the same number, they have no distance between them. 7 and 8 have a distance of 1 between them, and 7 and 15 have a distance of 8 between them. So we took the mean and saw, we just looked how far away from it each of these data values is it. Okay, and so now that we have the distances, I want to find the average of those distances. So we're going to add up these distances. So 5 plus 3 plus 1 plus 0 plus 1 plus 8. And I still have 6 terms. When I add that up, I get 18 divided by 6, and I get a mean absolute distance of 3. So what that means is the average distance from the mean is 3. So if you were thinking about it, I had 6 friends, and I have a friend that lives 2 miles away, 4 miles away, 6 miles away, 7 miles away, 8 miles away, and 15 miles away. On average, the average distance away from me that they are is 3 miles. So I found their differences. The average difference in the average distance from the mean is 3 miles. All right, so let's try and look at a couple. So kind of by itself, it doesn't really mean a lot. It's not until we start to compare them that we can, that it means something. So we're going to find the mean absolute deviation for these three data sets. So remember, the first thing you want to do is you want to find the mean. So that means you want to add up all of these numbers and divide by the total number of numbers. When I add those up, I get 45. And there's 1, 2, 3, 4, 5 numbers. 45 divided by 5 is 9. I want to find the distance away they are from each other. So 9 and 2 are 7 apart. And we're going to end up adding these together. So I'm just going to go ahead and put the plus there. 9 and 4 are 5 apart. 9 and 6 are 3 apart. 9 and 15 are 6 apart, and 9 and 18 are 9 apart. Okay, I still have 5. So what does that equal? When I add all of that up, I think I got 30 divided by 5. So the average distance is 6. So the mean is 9, and the mean absolute deviation is 6. Okay. Let's try it again. We're going to find the original mean of the distances. So we're going to 6 plus 7 plus 9 plus 10 plus 13 is 45. And there are 5 numbers. Oh, I also got the 9 for a mean there also. So now let's compare them. 9 is 3 away from 6. 9 is 2 away from 7. 9 is not any distance from itself, so we don't want to ignore that. We want to go ahead and put that there's a 0 distance. 9 is 1 away from 10, and 9 is 4 away from 13. So you would want to add those up and find the average of those. So we got 3 plus 2 plus 0 plus 1 plus 4 is 10, divided by 5 is 2. So they have a mean absolute distance. The average distance from the mean is 2. Okay, so what I want you to do, so look, we got our means. They're exactly the same, but their mean absolute deviations are different. So if we look here on our last one, this one's a weird one. They're all 9s. So when I add up all 5 9s, I get 45 divided by 5 for an average of 9. So they all have a mean of 9. But do you think this is going to have a lot of distance? Because they're all the same number. So let's look. 9 is 0 away from 9. 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 And 9 is 0 away from 9. Divided by 5. So my MAD here, I'll put these so we can see them. Our MAD here is 0 divided by 5, which is 0. Okay, so what's important is if I was comparing these, I would say this data set has the least amount of spread, and this has no spread because they're all the same number, so it had a MAD of 0. These numbers are pretty close together. They have a MAD of 2. These numbers are more spread out because we go from 2 to 18. This is only 6 to 13. This has a smaller range than this one, and this one's MAD is bigger. So the bigger the range, the bigger the average distance. So what I want you to take away is the closer the MAD is to the 0, the closer the MAD is to 0, the less variation there is in the data. Okay, so the closer the MAD is to 0, the less variation there is in the data. So the MAD here was 0, and there was 0 variation in the data. The MAD here is 2. We had a range of 7, and the numbers are all kind of alike. And it had, okay, but when I compared this to this has a range of 16, and its MAD is bigger. So the bigger the MAD, the bigger the range, the more varied the data is. Okay, now how do you think outliers might affect your mean absolute deviation? So if you think about it, you can have, remember the definition of an outlier is a number that's much bigger or much smaller. So if you have a bunch of numbers that are very similar, so we have 2, 3, 5, 7, 9. That's going to have a small MAD because that's only a range of 7. But then what if I had an outlier of 60? Now my range is 58. So what's going to happen is if you have outliers, it's going to increase your mean absolute deviation. Okay. All right, let's try some examples. All right, so we have a scenario here where we have the high temperatures for the past 5 days. So this must be in the summer because these are nice warm temperatures. All right, so first thing you want to do is you want to find the mean because we got to see how far away everybody is from the mean. So you're going to take each of the numbers, 90 plus 81 plus 85 plus 92 plus 82. And you're going to divide them by 1, 2, 3, 4, 5. So you get a mean of I got a total of 430 on the top, divided by 5. So I have a mean of 86. So I want to see how far away each of these are from the mean. And I'm going to find the average of that. 86 to 90 is a distance of 4. 86 to 81 is a distance of 5. 86 to 85 is a distance of 1. 86 to 92 is a distance of 6. And 86 to 82 is a distance of 4. So I still have 5 numbers here. When I add all of these up, I get 20 divided by 5, which is, so the mean absolute deviation there is 4. All right, what I would like you to do is I would like you to try number 3 on your own. Try it all the way out, add them up, find the mean, and find out how far apart each of them are from the mean. And then take the average again, and then come back and check with me. All right, so I added everybody up, and I got 785. There are 5 numbers, so I divided by 5. So I got an average, or a mean, of 157. Then I compared 157 to 174. They're 17 apart. 157 to 180 is 13 apart. 157 to 160 is 3 apart. 157 to 121 is 36 apart. And 157 to 150 is 7 apart. Add them all up, divide by 5. I got 76 divided by 5. So I had a MAD of 15.2. Okay. Hopefully this is starting to feel pretty okay. Let's go ahead and have you try number 4 on your own, and then come back to see how you did. All right, taking a look at number 4, I added everybody up here in my data set, and I got 57. There are 6 numbers, so I divided by 6 and got a mean of 9.5. Then I compared the mean to each number, 9.5 to 8, and got 1.5. 9.5 to 10, 0.5. 9.5 to 5 is also 0.5. 9.5 to 14 is 4.5. 9.5 and 4 are 5.5 apart, and 9.5 and 12 are 2.5 apart. Added those all up, and I got 15 divided by, that should be a 6, and I got a MAD of 2.5. So the average distance from the mean is 2.5 wins in the past season. All right, so hopefully this is helpful. I'll see you in class.